5-2 Day 1 Right Triangle Trigonometry. In example 1, we're going to use Pythagorean theorem to find the missing side, then find the value of each of the 6 trig functions. So hopefully you have your identity sheet beside you, and we'll start with Pythagorean theorem. Okay, so we have to find the hypotenuse. That's this side. We're going to use Pythagorean theorem. A squared, doesn't matter which side is A, plus b squared, I'm just going to make it 6, is equal to c squared. Let me write this out. A squared plus b squared is equal to c squared. C is always your hypotenuse. So we have 64 plus 36. Add those together, 100. You always square root both sides. If it comes out to be a perfect square, that's awesome. So C equals 10. So my hypotenuse is 10 units. Now we have to find 6 trig functions. So we have sine, opposite over adjacent, cosine, adjacent over hypotenuse, tangent, sine is opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So that's 3 already. 1, 2, 3. The other 3 are the reciprocals. The reciprocal for sine is cosecant, and we abbreviate it CSC. That ratio is hypotenuse over opposite. Cosine reciprocal is secant, and we abbreviate it SEC, and that's hypotenuse over adjacent. Tangent's reciprocal is cotangent. We abbreviate it COT, and that's adjacent over opposite. So we do have 6 trig functions that we're finding. Now, in our triangle, I'll draw it over here. Here's theta. We have 8, 6, and 10. According to theta, the 6 is opposite. 8 is adjacent, because it's right beside it, and 10 is your hypotenuse. So all you have to do is set up your ratios. You write it like this: sine theta. Opposite is 6. Hypotenuse is 10. And you reduce it 3/5. So when I do cosecant theta, it'll be the reciprocal, 5/3. Cosine theta, that's adjacent, which is 8 over your hypotenuse. Reduce it, 4/5. Secant is the reciprocal, so you just 5/4. Tangent, O over A. 6/8. Reduce it, 3/4. Cotangent, reciprocal, 4/3. And those are your 6 trig functions. If you remember from your summer assignment, we have what are called 2 special triangles, the 45-45-90 and 30-60-90. For the 45-45-90, you have 2 congruent sides, and we call them, or their side lengths are 1 and 1, because it's based on the unit circle. And the hypotenuse is always radical 2. For the 30-60-90, we have the short side, which is 1. Across from the 60 is the short side times radical 3. And across from 90, you double your short side, or 2 times your short side, and that's how we receive 2. And you need to learn these 2 special triangles. So now we're going to find the trig functions. I'm going to put SOHCAHTOA up here so you can remember. And remember, this is cosecant, reciprocal, secant, and cotangent. Okay, tangent of 30. Tangent is opposite, so we go to 30. We look opposite, and that's 1. and adjacent would be radical 3. Well, you always want to rationalize your denominator. That means you don't want a square root. So you multiply it by itself, and you're going to get radical 3 over the square root of 9, which is 3. And we're going to learn a lot more about these special triangles later. Cosecant of 45. Cosecant is hypotenuse over opposite because it's the reciprocal of sine. So go to 45, the 45 triangle. Hypotenuse is radical 2. And opposite could be either side, is 1. So that answer is just radical 2. Okay, part C, cotangent of pi over 3. Pi over 3, that is 60 degrees. So go to your 60-degree triangle. Cotangent is the reciprocal of tangent, adjacent over opposite. So from adjacent to 60 is 1. Opposite would be radical 3. Don't forget to rationalize it. So you're going to get radical 3 over 3. Now, part D, they want us to find tangent of pi over 4. Pi over 4 is 45 degrees plus cosecant of pi over 6. Pi over 6 is 30 degrees. So we have to do two things. Tangent is opposite over adjacent. So that would just be 1 over 1, which is 1. Plus cosecant is, we just did over there, hypotenuse over opposite. So go to your 30-degree triangle, and hypotenuse is 2. And opposite of 30 is 1. 2 over 1 is 2. Add those together, and you get a value of 3. In this example, they were given us sine and cosine, and we have to find the other trig functions. It says use identities, but what you can do is draw a triangle. You can put theta anywhere. And you know that sine is opposite over opposite over hypotenuse. So let's label this. So this is O, this is H. So opposite 3, hypotenuse 5. Cosine is adjacent over hypotenuse. Adjacent for hypotenuse we already have. Now they want us to find the other trig functions. So we're missing tangent, cosecant, secant, and cotangent. Well, tangent is opposite over adjacent. So opposite is 3, and adjacent is 4. Cosecant is the reciprocal of sine. So all you have to do is look at sine's ratio and do the reciprocal. Secant is the reciprocal of cosine. So look at cosine's ratio and do the reciprocal. Cotangent is the reciprocal of tangent. Look at tangents and do the reciprocal. And now you found all the functions. Now in this example, they want you to use your Pythagorean identities. So if you look at your identity sheets, you're going to see that Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. I'm going to show you two ways you can do this. So they'll probably give you sine theta is equal to 7 over 8. You could do like the previous problem and label your triangle. Remember, sine is opposite over hypotenuse. Opposite, hypotenuse. You can use Pythagorean theorem because remember we have to find cosine, which is adjacent over hypotenuse. We have the hypotenuse, we don't have the adjacent side. So what you do is You do a squared, we don't have, plus 7 squared equals 8 squared. And you solve it. You get a squared equals 15, square root, and you leave it because it's not a perfect square. So now, when you find cosine, it'll be the square root of 15 over 8. Now, you can also use the formula. Using the formula will require a little bit more work. We'll call this option 2. You can plug in sine in the formula, but you have to square it. And you just solve for cosine as if it was an algebra problem. So that's 49 over 64. And you would subtract it from 1, but I'm going to change this to 64 over 64. So you subtract that from both sides. And you're going to get 15 over 64. And you square root both sides. And you're going to get the same thing, square root of 15 over 8. So choose which option you like best, and that's the option you can use. Okay, finally, we're going to use our identities to find the value of each expression. Each of these expressions is going to give you a value or a number. So look on your identities and see what we can use to help us. So for A, I have cosine of 53 times secant of 53. Well, I know that secant is the reciprocal of cosine, so I'm going to use the reciprocal identity. So secant 53 is the same thing as 1 over cosine 53. Just going to put this over 1. So look what happens. This cancels, and you're left with 1. So that's your value. B, sine squared pi over 10 plus cosine squared pi over 10. Look at your identities and see what this is similar to. Oh, the Pythagorean identity. According to this identity, when you add sine squared of any angle plus cosine squared of any angle, the answer is always 1. So that one's nice. And then C, cosine squared 63 minus cotangent 63. Well, this looks similar to my Pythagorean identity again. But the difference is it has subtraction. So let's look at our identity. What would happen if I subtract cosine minus cotangent? So if I move this over, what does that equal? Cotangent squared. I'm left with 1. So that means that this answer is also 1.